from Germany, so thank you for the opportunity. Yeah, my presentation is basically about how you build the digital twin of a plant. So far we heard a lot about the value and how to use it and how to connect the systems, but today I'm going to discuss about how to build actually a digital twin. And I thought that I can start my presentation with kind of a rhetorical question that why do we invest so much money and effort and thoughts about building a qualified platform for a physical twin? So you need a really good platform for a physical twin, otherwise you know that long distillation column probably will fall down if you don't have a qualified platform. And the real question is, do we really need that qualified platform also for digital twin? So I heard a lot of projects all around the world, digitalization, they just start to connect databases, send data from here to there and then back there, and then analyze it, and then send the result back. And most of the time you don't see that digital column falling down, but you see that the digitalization projects are not bringing any value to the organization. So to some sense they fail to bring the value. And one of the reasons that we see that failure is because there is really no consolidated, reliable, and qualified platform that they build this digital twin above that, and then they can start to use it and then bring value out of that. So that is basically the topic of my presentation. Let's take an example here. It's a very small plant, and we want to build a digital twin of this small plant. And you see that of course, it's a small plant, but it's a complete one. So you have the tank, you have the pump in different locations. There is a measurement sensor and wires and cables, terminals in between, the control cabinet, DCS. So it's, in a sense, a complete plant. And if you want to design the digital twin of this plant from scratch, let's say it's a greenfield and you want to design it from scratch, the first model that you need is the physical representation of the equipment that you have. So you have, for example, a tank. This tank has two nozzles, a sensor and a valve below it. You have a pump, a motor, and basically every physical item that you have in the plant, you need a physical representation in the digital twin or the digital model of the plant. The next aspect that you need to design is the functionality of the plant. So how this plant is working. You have a big plant, you have subsections below that, and then up to the point that you have a measurement tag or a mechanical tag or an actuator tag. So these are the functionalities of the plant. This has nothing to do with the physical representation of the plant. This is the services that every one of the elements that you have is going to represent there. For example, from the control concept or from the functional perspective. And of course, there are associations between them. So for example, for a measurement tag, you of course need a valve and a wire. For a tank or for a mechanical tag, you need a tank and a pump. So there are associations between the functional perspective and physical perspective. And these associations are really critical for the complete plant data model. The next aspect that you have to design when you want to have a complete digital model of the plant is the civil engineering part. So buildings, rooms, different locations, they can be physical locations or they can be logical locations. For example, a Wi-Fi zone or safety zone are logical locations, and therefore you need a complete data model of those items in your plant. And again, there are associations between these different aspects. So these associations are there to give you the possibility of viewing your plant wherever you want to start and then navigating from there to any other aspect that you need. Otherwise, you don't know, for example, for certain services, what are the physical items that I need? Or if you want to go from a building, you want to see which physical items are there, you can start from the civil engineering part and then figure out what equipment do you have in that building. And the last aspect of the digital twin in our sense is the dynamics of the plant. So you have different scenarios for designing the plant, and then you have different operation modes, and all these operation modes and scenarios as dynamics of the plant should be modeled in your digital twin. And again, they have to be associated to other aspects of the plant. This is a really critical point, that you have the dynamics of the plant also considered when you want to design the digital twin of the plant. And of course, the documentation on this basis are just a side product. there is no one that says the documentation should be the main focus, and then based on that, we have to build the data model. Nowadays, people will design the data model, and documentation is basically showing what you have in the data model. So this means that when you have a pump, this pump can have a representation on the PNAD, on the PFD, on the 3D diagram. It really doesn't matter. It's just the same pump with different representations. And based on that, it is almost impossible, or it's not almost, but it's impossible that you have inconsistencies between your documentation, because they are just showing the same data from the same object as a single source of truth. So in past, we had a lot of change management between different disciplines, figuring out the quality of documentation. That is history. That is something that never happens with this data model that you have. And of course, based on that, you don't need multiple databases for different disciplines and different environments. This all can reside in one single database, which we call it single source of truth. And this is basically what we offer to the society as a platform. So this is the concept of our product, and the product is called Engineering Base. And this platform can be used from proposal engineering, from the first step of designing a plant, up to the point of the maintenance. So feed, process, instrumentation control, electrical automation, and maintenance, they all work together in one platform, regardless of where they are in different standards, different languages, it doesn't matter. They all work on the same platform. And you see that there is no boundary between them, so there is no import and export of the data between different disciplines and departments. And of course, there is no arrow, there is no sequence. They all work simultaneously together. Because there is one central data model, they all work together to make this data model mature enough that is representing at the end the data model of the plant. And in the second round, you see that there are different activities that are related to all other disciplines. For example, cause and effect, a migration of legacy data. In every plant, we heard that plants with 50 years of history, you can not just start from scratch. You have to migrate the legacy data. Execution of the project with a lot of EPCs and other contractors that are involved. Asset 360, change management. So these are all the activities that are related to all the disciplines, and this is why they are in the second level. So this is the product that is used mostly in Europe. It's probably none of you heard about Aquatech so far, but it's a very established environment in Europe, and companies like, for example, Equinor is using this product, and they call it the spine. It's not an abbreviation. They really call Engineering Base as a spine of Equinor, so all the engineering data in Equinor in Norway will reside in Engineering Base based on this concept. So, of course, this concept gives the reliable data and documentation to owner-operators and EPCs through the complete life cycle of the plant. And this is a very important point for us, that it gives the digital twin as a central position. So digital twin should reside in a central position, and everybody should be able to access to that. And that's why Engineering Base is giving that possibility to all contractors and EPCs and owner-operators in a way that they can access digital twin in one central point. They don't need to connect different points together to figure out which data they have to use, because having data is one thing, having a single source of truth is another thing. Just figuring out which data is the right one to use. And that's really an important point, because if you don't know which data you have to use for what purpose, then you have another problem after you get all this data and digitalization. And that's the problem that we want to avoid by this single source of truth concept. It's, of course, scalable into different industry sectors. If you have a power plant, or if you have a refinery, if you have an offshore or onshore oil and gas, like a petrochemical company or refinery, all of these types of industry sectors, up to the point like a terminal for tank farm, these are all the same concept. So all of them will use these 5 aspects of data model that I mentioned, and they design the digital twin of their plant on that basis. And also, it's scalable in different types of the companies. If you're an owner-operator, you need to have this data model as your plant is the same property that you have. You have the real physical plant, and you need the data model of that plant. And it should be as-built data and documentation. It cannot be an obsolete data. You need it always as-built. And of course, all the engineering contractors are pushing their data and making this data model more mature in a way that they design the data in their tool, regardless of whatever tool that they have, and then the platform is able to grasp that data and import it into the central data model. The operators, the ones that are operating the plant, will use this data, will consume this data to do their job, for example, to have the OTS or compare the live data with the design data, and whatever other aspects that we heard a lot about, the values that can be generated out of the data model. We are not into that business. We are in the business of creating this platform for the data model, for the digital twin, that it makes it possible for doing something like a predictive maintenance. And of course, the maintenance contractors, they can use the as-built data and documentation to design the maintenance of the plant, yearly maintenance, and everything else that should be designed based on the as-built data and documentation. Again, the data that is obsolete is not going to help anyone, and the data which is not clear what is the purpose of that data and how it should be used also is not a valuable data. So for us, it's really important to have a valuable data, a data that is clear for everybody how to use it in a single source of truth, in a single source that everybody can use it later. Of course, this is not going to happen in a night. We heard it also of onboarding people and so on. This is a project that is going to take a month and starts with consulting, onboarding people, discussing with people, and changing their mindset from AutoCAD and Excel into a data model engineering perspective and work. It needs a lot of analysis of workflows, how they work today, how they have to work in the future, because changing the workflow of a company is just not like changing a tool, and then from today to tomorrow you have to say, okay, now you have to start to design the digital twin. It doesn't work like that. You need to analyze the workflows that they have today and somehow figure out a way from today up to the point that you have the digitalization or complete digital model of the plant as a product of the design and engineering phase. So there is a really big and a long journey, and this needs a comprehensive project plan. And this is what we did in different customers around the world, to design a project plan for their digitalization journey, independent of the tool that they have right now and the tool that they want to use in the future. This is more about the organization and the people, and that's why we need this consultation. You need a rollout strategy for the IT. IT is one aspect of this thing, and it's really an important part. It should be scalable. It should be possible that you have access throughout the world. You cannot, as we saw it in the Corona phase, it was the situation that people around the world are working from the home, and they have to be able to connect to this platform wherever they are. We have companies that they are working in India, in UK, in US, in Germany, and they have different languages, they have different time zones, even different standards, metric unit, imperial unit. So they have to be able to all work together in one central data model, regardless of their environment and their situation. And that's the rollout strategy in the IT environment. And of course, a lot of training and support is needed once you want to start this journey. So to summarize, Engineering Base, as I mentioned before, it's a unique engineering platform for complete plant lifecycle, that you can design the complete data model of the plant. And it was not made based on this hype of digitalization or digital twin, that we merge and merge different products together and then present it as a platform. It was designed genuinely around 15 years ago, around 20 years ago, as a platform for the complete plant lifecycle. So it was designed to be like that from 20 years ago, and now it is used in all the customers that we have for plant lifecycle. It's basically from the feed up to the last point, the last cabinet that you have to design. Engineering Base is supporting there. It's cloud compatible and it's open system. Some of our competitors, they decided to play this monopoly that you can design the environment there, but it's not accessible by anyone else. You have to export the data to Excel and this kind of games that you have to play until you get the data somewhere. But we decided that when you have the data model of a plant, it should be fully open and accessible to anyone that has access permission to get that data and write to that data. So that's a very important point for us, that it is open and accessible through the web services. It has a Microsoft look and feel. The point is that all that we discussed together with digitalization and data models and digital twin, at the end of the day, there is a process engineer sitting in front of a computer and he needs to design the P&ID. We cannot convince him that you have to design these graph models and all this data because I need a digital twin. He has a job of designing a P&ID as fast as possible. So we take that into consideration, and we design the environment for different disciplines, for process, for instrumentation, for electrical engineers, that they can continue to work as they are used to work, and the system behind is generating the data model and the digital twin based on their actions. So when there is a PNID guy sitting in front of a computer, he designs a PNID. The system will recognize that there is a tank which is connected to a pipe, and this pipe has different inline devices, and each of these inline devices is connected to a wire. And this is what the user is doing. He's graphically designing, and behind the scene, the data model is generated. And of course, this data model is used later for all kinds of reports and any kind of accessibility of data to other tools like predictive maintenance and other activities for data usage. And of course, it's a future-proof system because we designed it in a 3-layer architecture that you have a central database, then you have the application server, and then you have the client, which is completely scalable as one laptop that you have everything together in one laptop, or you can put the database on the cloud and then make the clients on different client machines, and then they can access the application server and database from different routes like cloud environments. So this is the engineering base, and as I mentioned, companies like Equinor, they already jumped on this platform, and just quick words about us. Equinor is one of the 7,000 customers that we have around the world, and we are in this game since 37 years, so we are not a startup company. It's been a long time that we are in this game, and our customers are relying on this platform for the complete life cycle of the plant. That's why I thought it's a good chance to present also this platform here in US, but this is a complete new market for us, complete new environment for us. I know that it will have some challenges itself, but in Europe, that's the flavor of digital twin and how it is used in that environment. Thank you very much. Well, this is not our responsibility to main. We are a software company providing the platform for digital twin, and a company, I just mentioned Equinor too many times, just a company like Equinor, when they design the digital twin, their responsibility is to keep it as built and equal to the physical asset. So when, for example, they use technologies like OPC UA, that they connect the data model into the live data from the plant, and they always see the difference between the live data and the design data. And when there is a change, when, for example, you change a valve in a maintenance procedure, this information will be sent directly back to engineering base, and then they get a notification that this object should be updated. And just remember that when an object is updated, all the documentation around it will be updated. So it's not that you have to update your documentation one by one. When you change the object, the whole life cycle is updated, and then you don't need to care about other documents or PFD, PNID, and everything else that is around it. Good. So if there are no further questions, thank you very much. Thank you.